Mohammed, you can hear me, right?
Yes, yeah.
Excellent, excellent. So I'm just gonna stop the music so that I doesn't disturb people. So we just gonna get a chance to leave people in, to let people in for the next 30 seconds, and then we make a swift start, right? Because I think we have a very important topic to cover, and we want to make sure that we go through all of that. So do we have? So we have already altogether 23 people that have signed up already. That's great. I'm sure there's going to be more people joining in because there's always people that are late, but that's okay. So let me make a start. So welcome everybody, and welcome to this joint session of what is best for Africa. We call it WEBA, right? So it's a joint session by Clean Energy for Africa and Renewables in Africa. So the whole idea of this session and WEBA in general, it's for us to explore the opportunities and the challenges of the renewable energy sector in Africa and bring to you the best experts for you to discuss and exchange with them. So we have today one of our top man, Mr. Mohammed Saad, working for APD Engineering in Australia, and I'm sure he's going to be covering a lot of ground, right? So before we kick off, so some house rules. You find out that most of you, your camera is turned off, is done on purpose, and we're going to ask you please to leave that off. So your microphone as well, you can't unmute for the simple reason that we want to make sure that there is no disturbances when we go through our webinar, right? But you can ask questions in the chat. So my colleague Mohammed would definitely pick up the question. In the end, we're going to address that. Yeah. And last but not the least, send us your feedback at the address that you see there. But we want to make sure that you also enjoy yourself, right? It's very important. Yeah. So let me move on. What is the agenda we're going to cover today? So I'm just going to have a brief introduction what renewables in Africa is. And we do the same as well with Clean Energy for Africa, just in case that's the first time you come across us, right? So we want you to know what we're all about. And then Mohammed's just going to make a nice introduction to the topic and the meat, right? So the real food going to be delivered by Mohammed. So I'm hoping that you're hungry because he has a lot to give you, right? We're going to end up with a Q&A and conclude with just some few remarks in the end, right? So I'm hopefully you are very excited because I am excited. And without further ado, so yeah, I'm just gonna dive in. As I say, we speaking, make sure that you send your questions. We're gonna collect them, right? So what is Renewables in Africa in short? So we are a clean energy engineering company and we serve two purposes. So that's why I had a two-in-one. Not only we are an engineering company doing project origination and project development as well as market studies, but we are also a media platform. A lot of people will know us from our media platform activities because it is important for us to raise the awareness of renewables energy right across the continent. That's why you have us talking about different topics. That's why you have us bringing experts that you can see today with Mohammed Saad, right? So by the way, Dr. Mohammed Alaj as well. So he's another top expert. So I'm sure he's going to be granting you some of the key knowledge that he has in another session, right? So that's all I can quickly say on us. So we know that having local solar developer is very important. So that's what we've done recently. We've launched a solar masterclass to train 1,000 solar developers in the continent of Africa. So we have a free workshop that is coming next week, right? So next Wednesday. So I strongly encourage you. So if you're not booked up for that yet, make sure that you do it. So the link is there. And then I'm just going to make sure that I'm just going to add as well the link into the comments as we go into the session. So that's it for me. Let me just leave the floor to Mohammed to introduce Clean Energy for Africa and take it forward. As for me, I'll see you back when we do the Q&A and the introduction. So Mohammed, you want to take it forward, please?
Yes. Thank you very much, Tony, and welcome everyone. First of all, thank you, Tony and Renewables in Africa, for partnering with us in delivering this webinar on a very important topic. And hello, everyone. My name is Mohammed Al-Haj. I'm a renewable energy engineer and researcher, and I'm also the founder and director of Clean Energy for Africa. Clean Energy for Africa is a youth-led African think tank and knowledge platform that promotes renewable energy in Africa through advocacy work, articles, news, webinars, along with training and mentoring young professionals. Our mission is to empower the next generation of renewable energy professionals and engineers in Africa. Clean Energy for Africa has recently been recognized by the United Nations Major Group for Youth and Children through the SDG 7 Youth Constituency as being among the top 98 youth-based initiatives that support SDG 7. And coming now to the topic of today's presentation, which is about the integration of variable renewable energy in the power system. Very important topic, especially given the increased penetration levels and the large number of projects that are being planned and launched in Africa. And for this topic, we have an expert speaker, one of our team members, our technical consultant, Engineer Mohammed Saad. I'll be introducing him. Engineer Mohammed Saad obtained his bachelor's degree in electrical engineering from Alexandria University in 2004. He has more than 15 years of combined full-time experience in power network planning, design, protection, and system studies, including generation, transmission, distribution, renewables, power network modeling, and steady-state transient analysis. Mohammed initiated, monitored, and managed many of the power system studies projects in the Middle East, North Africa, and Australia. During the course of his professional career, Mohammed has extensively been involved in different power sectors such as electricity, water, and even oil and gas, petrochemicals, and the renewables industry, of course. Currently, Engineer Mohammed Saad is living in Australia and working as an embedded power systems consultant to the Australian Energy Market Regulator. Being a member of the National Connection Team in the Australian Energy Market Operator, his main duties and responsibilities is to assist in renewable energy projects integration and its connection into the Australian grid. And as many of you would know, Australia is actually one of the largest and one of the most progressive and developed renewable energy markets. So I'm really glad that we will be able to learn a lot from Mohammed during this presentation. Engineer Mohammed Saad is also a member of Engineers Australia, IEEE, and Australian National Engineering Register. He's also recognized and registered as a Chartered Professional Engineer in Australia, Professional Engineer in Queensland, Professional Engineer in Asia Pacific Economic Cooperation, and International Professional Engineer. Quite a resume there, Mohammed, and we really look forward to this topic and to for you to tell us more about the challenges of renewable energy penetration on the power system. Mohammed, the mic is yours now.
Well, that's a lot. Thank you, Tony, and thank you, Dr. Mohammed, for the brief introduction you've made. Well, as far as I know, guys, the audience that joining us today are coming from different countries, so which is a positive sign, I believe, and it reflects basically the good diversity that we have tonight, which I really like it. The only concern I have is at the moment it's basically what to say, because I reckon it can be morning time, afternoon time, or evening time, depending on your current location around the world. But you know what, the best way is a safe way. So hello everyone and welcome. Yeah, thanks for giving me the opportunity to and having me today as a guest speaker to just put some thoughts together and have a bit of discussion on the and sharing the knowledge on one of the most important and interesting topic nowadays that many engineers are care about, which is a challenges of renewable energy penetration on power system. That's a very important topic, and I'm happy to be with you guys today or tonight to just have a bit of sharing the knowledge in this topic. Just for your information, this is going to be a focused webinar, so we aim to make it short. It's going to be around 30 minutes, since I won't be able to cover everything in more details. However, I'll try my best to cover the basics and at least the fundamental understanding of power systems and renewable energy penetration, as well as the possible solutions for the challenges that we're facing at nowadays. Yeah, so can you see my screen, guys?
Yes, Mohammed, we can see your screen.
Yeah, I
Yes.
hope you
Yep,
see my
everything
screen.
is fine
Okay.
on your side. Yep.
Yeah.
All right, cool. So in the following slide, I'm going to speak about basics of power system, and then following with a little bit of talk about Paris Climate Agreement. And then we'll go to the advantage of renewable energy, challenges for renewable energy, the impossible solutions, and finally, I've put some recommendations that I would like to see in the future. So mainly the power system, let me just move this one a little bit here to the left. But mainly the power grid is a network that deals with the mainly three items: the generation part, and then the uh, consumers, all right, and in between all the way from generation to the consumers, that's gonna be the transmission system. So that's mainly the three main parts of any power network. And since we have this more than 100 years ago, and the electricity needs at that time were very simple. So the main characteristics of the power generation was firm. So we understand and know exactly what we are generating. And the technology used at that time was a synchronous machine technology. So I think all of us are aware of this technology. And the system was localized, which is very important, and built around the communities. And the main role of the grid at that time, and it's also nowadays, is to generate the electricity and transmit it to the consumers, and of course build them once every month or so. Some countries build every 3 months, like Australia. So this way of communication, that was considered a one-way interaction, which makes it difficult for the grid nowadays to respond to the changes occurring to the network, which basically the evolving renewable energy penetration to the grid. And that's why the smart grid concept has been introduced to provide a solution for this problem and to provide a two-way dialogue between the utility and its customers. So it's not anymore the power is generating from the generating plant, which were localized at a certain places. And nowadays, a rooftops PV system can talk to the grid. It can import and it can export as well. But this is not an easy. There are lots of challenges here. We need to develop the lots of network automations, develop more control strategies, and develop different tools which they all work together to make the grid more efficient and greener. Just a little bit talk about Paris Agreement. It's basically a legal document which binds 196 countries around the world that they have signed that agreement in 2016 in Paris. The agreement ultimate goal is to holding the increase of global average temperature to be 2 degrees Celsius. And there is an ambitious plan to even make it better and not to exceeding 1.5 degrees Celsius. The plan or the agreement is to review the targets at every 5 years time, and there will be some obligations on the rich countries, okay, to provide some finance and budgeting the renewable energy projects, okay, to the developed countries around the world. So this is a very ambitious plan, and from that time, all the countries are really in a race to building lots of renewable projects and trying to reduce the CO2 emissions. And in that regards, actually, each country must determine and plan and report on their contribution that's undertake to mitigate global warming. It's not a compulsory, it's not forcing for the country to achieve a certain target. It's the country itself that it set up its target, but the most important one is for the next one, it should be higher than the previous targets. So that's now an obligation for nearly the whole world at the moment. Now, because of that agreement, lots of countries, as I've mentioned, they are in a race to building, renewable energy projects in their lands and connected to their grid. And the reason of start using this is the so many advantages that the renewable energy has. I believe all of us know those advantages, but let's just quickly go through it. So it's basically a clean source of energy. It's a cheap, it's a sustainable, so it won't run out, and the maintenance requirements are lower. And the most important, there is no pollutions comes out of it, and of course no greenhouse gases. So that's we'll be having a positive environmental benefit. And I believe there are so many other benefits as well. Now, I'll just talk about the main challenges from my perspective on renewable energy penetration into power grid. So the first one is the renewable energy, it's not dispatchable. So that means we cannot turn them on when we need them. And of course, we cannot turn them off when we don't need them. So improve the wind blows and sun shines at their schedule and not necessarily the schedule that we want. So when the sun shines here, the PV system is working, all right? And during the same day, it may not, the wind is not enough to generate enough power from the wind. But on a rainy day, cloudy day, for example, okay, the PV system will not be generating enough power, but the wind turbines will be doing its job. All right. The second challenge I would say here is the renewable energy is intermittent, and sometimes they are not well aligned with the demand. So as we all know, the supply and demand need to be instantaneously balanced all the time. So if the wind blows or the sun shines when we need electricity, then we are very lucky. Otherwise, we are not. So if you, for example, if you look to the typical daily profile of PV power generation and load demand here, so the red one is a representation of the load demand, and the blue one is the for the PV generation. So as you can see here, okay, when the PV start to generate power, all right, so it can cover the load from that point up to that point, even though we have a surplus power here that can be used, for example, to be stored in like batteries or so, and to be used in different time, which can be here or here. But the main problem, if we have a cloudy day and we are not able to generate enough power from the PV system. So if we assume the blue line, it just goes below the red one here. So that means there will be a gap, and that gap needs to be fulfilled from other source of power. So with the good weather prediction, we can predict where are those gaps, and we can plan our system well to cover those gaps and fill it by other source of energy or source of power. So the variability and uncertainty of renewable sources impact the ability to effectively balance supply and load demand. So that is one of the challenge. I would also put it here. Another challenge, which is, if we can answer this question, is the supply where we need it. So unlike the traditional generation plant that we normally build it where the demand exists, renewable energy project is different. So it can be built only on a specific location, depending, of course, on the climate conditions and the geographical locations. So we cannot build a wind farm at any place we want. We cannot also build a solar farm at any place we want. There is a site limitation, there's a weather limitation, and so on. So what's that mean? It will lead to another challenge, which is the higher initial cost. I was reluctant to put the initial cost for the PV system and the panels itself, but I understand the technology, it's becoming more advanced now, and the cost for those equipments are dramatically dropped if we compare their price maybe 15 years ago or 10 years ago. But the main cost I mean here is to build the infrastructure necessary to transfer the generated power from those wind and solar farms, okay, to the location, to the load centers. So that's basically the one of the challenge as well. All right. On the other side, increasing penetration of renewable energy brings more challenges, and these are like a technical challenges and uncertainties in power system. So one of those challenges is the system inertia. So if you look to the graph here, all right. So when the system consists of synchronous machine, which can be a hydro power plants and coal power plants, nuclear, and even small penetration or portion of the power system with the PV and wind system, we still get a higher inertia. So the inertia is basically it's basically related to the synchronous machine design and operation. So, and because that the renewable energy sources doesn't really have a rotating mass such as PV, so there is no stored energy will be on the system, except maybe for the wind turbine, which has a small amount of inertia due to its mechanical parts. So what's the challenge here? The challenge is the less the system inertia is, the rate of change of frequency increases, and hence we need to act in a faster time. So the response for any load shedding or maybe tripping of a generators, the frequency will be very sensitive to those all events. And previously we were comfortable because the system was very strong and we have enough of synchronous machines. But with the increasing of penetrations of the renewable energy, the inertia become very low, and we couldn't really control frequency, or sorry, we couldn't really managing frequency in a proper way. So this is again the system frequency here. Firstly, the frequency, as we all know, it's a very critical number in power system, and it tells us how much the system is synchronized, and as well as the status of supply demand balance in real time. So our main goal is to operate at 50 Hertz or at 60 Hertz, depending on your operating frequency in your country. But this is the equation. So if the demand increased and we have less generation, the frequency drop from 50 to be below 50, and the vice versa. If the supply is more and the demand is less, the frequency increase. All right. Sorry, I have to go back one more time. So the risk here is that with the increase of solar and wind in the network, the conventional synchronous generation will be displaced, which makes sense because the final goal is we need to reduce the CO2 emissions, and we need to get a clean source of energy. So all the traditional power plants will be retired. So eventually the controlling system frequency become a challenge. So that's also one of the challenges, I would say. Now, before going to the following slides, I would like to talk a little bit here on wind and solar generation characteristics. So as you can see, the modern wind and solar, the modern wind and solar generation projects, it's basically an inverter-based technology. So the system is actually connecting the power electronics with the grid through converters or inverters. So this type of power electronics devices, they are typically including fast active current and reactive current control and required to be synchronized with the grid voltage. So to achieve this properly, that required a grid to be strong. So what's going to happen if we integrate our wind or solar power plants into a weak grid? Then we need to introduce something we so-called a system strength, which indicate the ability of power system to maintain the voltage during normal and abnormal operating condition. And to quantify the how the network is strong, we have what you call a short circuit ratio. In short, it's SCR, which is an index used to assess the system strength for the connection of power electronic sources. So in a formula, the short circuit ratio at any point in the system is the fault level at that point divided by the plant ratings in megawatt or in megavolt ampere connecting to the same point. So the conclusion here, the lower of the short circuit is, the weaker the system is. So our goal is to really trying our best to assess the short circuit ratio to identify the risk and mitigate it. In addition to that, the OEM or the power electronic source manufacturer should provide a clear statement regarding the minimum short circuit level in which their equipment can reliably operate. So the risk here is that for the low short circuit network condition, it becomes more challenging, and hence we need to do a detailed power system modeling and studies, which we call it EMT or electromagnetic transient analysis. As you can see here in the, we have two waveforms. One is it's both for the event of fault. The left one is a representation for the high system strength, and you can see the waveform during the fault, it's pretty much stable. But for the low system strength, the voltage waveform, it's really distorted. So there is a high chance that the system may not be able to operate properly during the fault events, and that may lead to the wide blackout. Another challenge as well is the quality of supply. Because as I've mentioned in the previous slide, the wind and solar generation characteristics, they are all made of power electronic devices and interfacing this with the grid. So as we know, all the power electronic devices, they are non-linear loads, and they are definitely source of harmonics. And by the way, quality of supply, it's not necessarily to be only harmonics. It can be other stuff as well, like flickerings, for example, or swelling, for example. But in this presentation, I'll just talk about the harmonics. As we all know, the harmonics is a serious issue now in power system, which mainly causing a lot of problems like overheating, voltage stresses, poor power factor, and possibly it can lead to the system resonance. And the main challenge here is how to maintain the individual harmonic distortion as well as the total harmonic distortion at any point in the network to be below the standard limits. So the green waveform here is a pure sinusoidal wave, and because we have a yellow one, which representation of the third harmonic. Sorry, the blue one is for the third harmonic, and the blue one is for the third harmonics, and the yellow one is for the fifth harmonics. So in total, we are getting a distorted waveform, which is the red one here. And that waveform will cause all these problems in the system.
Mohammed, sorry to interrupt, but we're approaching the end, so I just want to give you a heads up. Yeah.
All right, thanks, Mohammed. I'll wrap up quickly. Thank you. All right, so now we reach to the possible solutions. So in my opinion, these are some of the possible solutions that might help to, get rid of the challenges or at least minimize the amount of risk that we have. So if we want to use the intermittent renewables and assure supply, we may choosing anti-coincident site and make the larger area grid interconnections. We may balance anti-coincident renewables, so we might have a mix of wind and solar. We might balance storage systems, so we might have a pump hydro plants and battery as well. We might balance with the other dispatchable renewables like hydro and geothermal. We might balance with the dispatchable generation plant using natural gas and combined cycle. The possible solution and mitigation measures for the low system strength issue. Maybe we can build a new transmission lines and transformers with the lower impedance values. We can reconfigure our network. We can install synchronous condensers, which will help to increase the system strength and also provide inertia and also provide a dynamic voltage regulation. We can install the static VAR compensators and STATCOMs, which will enhance the dynamic voltage regulation as well as control challenges. The last one, of course, we can reduce the register plant capacity, and this is maybe the last thing we want to do. So if we have a plant registered with 100 megawatt solar, we might ask them to limit the dispatch output power from 100 to 80, for example. And this is one of the solutions as well to mitigate the low short circuit ratio in the network. A possible solution to managing frequency is to come up with like a narrowed dead band for the frequency. So we make the frequency response from all the generator quicker, so we can manage the risk of the system over the coming years. Also, we can develop some frequency control work plans to make it more efficient. The possible solution for harmonic distortion is to, of course, installing harmonic filters. Now I'm wrapping up quickly here. So the recommendation I would like to see in the future is as a step one is to do a short circuit ratio estimation. And that will help us to evaluate the connection application and mitigate the risk. The second point is to do a power system modeling and studies. That's very important, and that has to be done by qualified engineers. Previously, the RMS studies was the main type of studies, but nowadays, because of the inverter-based technology, we need, in addition to the RMS studies, we need to go for electromagnetic transient studies as well. Number 3 is to modify and adding some control features to improve the generator performance, and that's maybe with the OEM. One of the recommendation I would like to see is the collaboration between system planners, operators, developers, and OEM. That's mandatory. And we need more investment in R&D in renewable energy and specifically in energy storage. So it allows us to, store more electricity and use it during peak times. And the last recommendation is that, we have some public policy that, provide enough support and give more intensive for the utilities and network service providers to invest in renewable energy. I think with this, I'm concluding my presentation. Feel free to reach out. You can use my LinkedIn profile. You can, talk to Clean Energy for Africa as well. So thanks for your attention.
Thank you very much, Mohammed. Really great presentation, honestly, quite thorough and quite detailed as well on the electrical engineering part, which is quite important. We have just because we're kind of over the time, so we'll try to make it brief with the Q&A. So there's one question from Abdulaziz. He's asking, what is the difference between capacitor banks and synchronous condensers in the operation?
A capacitor banks is a static device, so it will not do much during dynamics. So the capacitor banks, as far as I know, it will inject reactive power during a steady state and do maybe some power factor corrections. But during fault, we need the dynamic response from a device that will, dynamically respond to the fault and injecting a reactive current to the system to support the voltage, which the capacitor bank won't be able to do it.
Thank you, Mohammed. I have one question actually. So we've been reading that there are some new technologies that could help navigate the issue of system inertia, like grid forming inverters and other technologies maybe being developed. So I don't know if you could give us your thoughts on like what is the latest technologies being developed to mitigate the issue of system inertia for a grid that has a lot of variable renewables.
Yeah, that's right. Just for your information, this is a very brief, presentation, and each topic in this presentation can be like a webinar by itself. But coming to your point, Mohammed, about the system strengths and grid forming inverters, I agree with you. That's one of the solutions because, as I've mentioned, let me just go back maybe quickly here. As I've mentioned here, for the system strengths, all right, yes, all right. So that, okay. So because of the nature of, inverter-based technology, all right, we need to be in synchronization with the grid voltage. And for the grid forming inverter, I think you are not really dependent on the grid voltage. You can create your own voltage. So in different way, you are independent from the grid voltage, so you can, be more stable. So yeah, I agree with you. That's one of the solutions, and it has lots of R&D. Yeah.
Great, thank you very much, Mohammed, and. Yeah, thank you, everyone. I hope everyone benefited from this presentation. And as Mohammed mentioned in the end, please do feel free to send any questions you may have or further comments to the speaker through info@cleanenergyforafrica.org. To conclude, I'm just going to give the mic now to our man, Tony from Renewables in Africa.
Yeah, can you hear me all? In fact,
yeah.
I think we still have a good 19 minutes, just in case there are people that have questions, and they feel free to ask because Mohammed is here to do that. Obviously, we're planning to have some other sessions for you to go more in depth and learn more as well. But I also want to say just a quick shout out to people that are following us from Facebook, because we're streaming live on Facebook, and I can see as I'm speaking to you that I have 16 people that are connected, and I'm sure a lot more will be watching the recordings, right? So yeah, because it's all about bringing to you, as I say, raising the awareness for renewables energy, so that people can get to know what are the challenges, but also the opportunities to make sure that we can bring in more solar, more winds, more hydro into our continent. So that's what I wanted to say, because I think we still have some minute, because I don't want to close in if people still thinking about a couple of things they want to be asking. So people in the chat, because I can see there are 36 people connected. So don't be shy. As I say, so you attending this, you paying with your time. So so tell us if you have any sort of question. So while you're thinking about a question, let me just ask a question to our expert. So Mohammed, I think you had extensive experience working in Australia, and I'm sure in many companies. So what sort of motivates you to really come and do this session today? Let me see, Mohammed, hopefully you can unmute yourself, but yeah.
Sorry, Tony. Yeah, can you repeat the last part, please?
So I was saying that, with your extensive experience, right, in Australia and working for different companies. So I just wanted to understand what really motivates you, because what people don't know, and is important to raise that. Over there, it's almost it's past 10 o'clock at night, right? So you're staying up that late to come and share your knowledge with people. So I really want to understand what actually really motivates you to do that, because you should be sleeping by now.
All right. It's not really. I like to stay a little bit late, and that's the way I have been grown up back in Egypt before coming to Australia. So Egypt used to have like a long night life, not like here in Australia. People like sleeping very early, but yeah, I'm staying a little bit late to do some finishing some work, or to read something or watch something. But coming back to your question, Tony, what motivates me to like deliver this type of webinar is my wish to share the knowledge with the young engineers, and start doing some volunteering type of work. It's kind of paying back to the community, like after now 15 years of experience working in this area. I wish to to share the knowledge to someone who can keep going, because that's the only thing we guarantee, that the knowledge remains, and not like stopped at some point. Yeah, so and I wish all the engineers doing the same. I know everyone is getting busy in his own life, and building his experience or whatever, but at some point in time, that need to be the way how people should think. Yeah, that's I hope I answered your question, Tony.
You answer very well. I can see as well in the chat, people are asking whether we're going to be sharing the material. So yes, we're going to be sharing the presentation. But what I want to say is, actually, I know most of you, when you get a presentation, you're just going to take a look at it and just forget about it, right? So, right, guys, as I say, knowledge is not power. I mean, basically, share knowledge is not power. Knowledge is only power if you apply it, right? So, and basically, you hear, we still have, as I say, 40 minutes to go, or maybe 10 minutes to go. You have the expert in front of you. Ask questions. That's how you engage, and that's how you get to know, right? It's not just to say, because I know, you have hundreds of webinars. You're going to take it and you forget about it. Now, we don't do that here. You guys need to ask questions. So I have one question that I've seen, a very courageous man. Let me just acknowledge him. So what was his name? So let me just check.
Kristen.
Okay. He was asking about the political and regulatory. What name was it, Mohammed? Can you see him? Okay, that was, yeah, Christine
Yeah.
Ain. So thank you, Christine. That's what I want. So Mohammed, the question is, what do you think about the main political and regulatory challenges? So in bringing renewable into the grid?
Um, I think I think mostly in from my perspective, I think the financials they are one of the main challenges for the regulators and to invest in this type of technology. That's one thing, and the other thing I would imagine is is because we are dealing with lots of uncertainties because of this type of penetration. So the solution for this type of issues is that if we know the problem well, all right, that's first step, we will be able to solve it. So with a little bit of investment in R&D, that would help the decision makers to to go forward with their plans. Other than this, I think the challenge will be still there, because if you deal with something unknown, you won't be able to make decision. So yeah, we need some, as I've mentioned in my recommendation here, we need more collaborations between all the parties. We need more investment, and that will be a a roadmap for the decision makers to come up with their decisions and keep things moving forward.
Okay, good.
I
Let
hope
me
that
ask you,
answered. Yeah.
uh, Christian, I think if the response is okay, just let us know in the chat, please. So if not, if you have a follow-up question on the back of it, please let us know. As I say, we still have a couple of minutes to address a couple of questions. So, Mohammed, as you were saying, so building the continent requires a lot of capacity building, right? So that's very important. I can see there's a thumbs up from Telhas, who's one of my friends. So she has joined us. Hey, Telhas, good to see you. So I was saying, Mohammed. So building the industry in the continent require capacity building. So that means we need more local solar developers, wind developers, and so on and so forth, because the continent can't just rely on people, coming from abroad and doing it. There's nothing wrong with that, but I'm saying, obviously, for a more sustainable pathway, there needs to be a number of skills on the ground. And the reason I'm saying that, because Egypt, because we've written a book on wind energy in Africa. Egypt, it's actually the ground zero in terms of wind energy in the continent. Started all the way back in 1980s, and that's why there was a sort of local supply chain over there, which is great. And then I know we're doing our masterclass where we, as I mentioned at the beginning, looking to train 1,000 solar developers, right? So I can talk to you more about that for people that would attend our free workshop that we're doing next Wednesday. But I wanted to ask you, Mohammed, to build that local workforce, a man of your experience, what would you say is the faster way to that? Because this is some of it are quite technical. How do you think, there's no wrong or right, but I just want to have your own personal opinion. How do you think we can make sure that a lot more people on the ground acquire this kind of skills that you have?
Yeah, that's a good. Thanks, Tony. That's a very good point you've raised. And just coming back to my previous answer to your question, that was my intention basically, is to promote the building capacity for the young engineers. But how to achieve that? In my mind, that can be done in two dimensions. The first dimension is to start with the universities. So the young engineers and the grad engineer, they should be aware of renewable energy. We need to raise the awareness of those young people about the benefits of renewable energy, the challenges that we are facing at the moment about the renewable energy, and how we are thinking the solution might be, looks like. So we need to raise the awareness at this level, plus a what you call it, the celebrities, or what you call it, the materials in the university. It has to be some subject that teach renewable energy in more details. One thing also I think it's a big gap is the lack of using the tools. which will help engineers to do the required power system studies and modeling. So I assume that there are now maybe few of them are maybe known to us here in Australia. I'm not sure whether it's been known in Africa as well. So that's also a gap. So we need to work in like different axes to make sure that the engineers are capturing the importance of renewable energy, the challenges of renewable energy, and how to do the required system modeling and analysis to solve their problems. So this is one thing. The other dimension is to look to the engineers who are already working in the industry, and they would like to be part of the renewable, projects. So they need a transition plan. So I think the transition plan has to become up from a private sectors that provide sort of trainings for them, or it has to come from the universities as well to provide some, academic courses for them to help them to be, make that transition smoothly. And also maybe the governmental, incentives should be there all the time for the young engineers to encourage them to, go for these type of, steps. I think that's what I believe should be.
Okay, thanks for that. I know it's a tricky question, so not easy to tackle, but I appreciate that you took the courage to tackle it. So as we're coming close to the end, I just want to go back to my colleague and partner here, so Mohammed Alaj, because I was thinking, Mohammed, in a couple of minutes, I just wanted you to talk about the program that you've run, where you were training, I think it was 3 to 4 young people that wanted to step into the, because I just wanted to share about the successes of this program. And I know that you're preparing for a new edition coming. I just wanted you to touch on that, just sort of as a compliment to Mohammed's response.
Great. Yeah, thank you, Tony. Yeah, so we actually had our first capacity building program at Canadian for Africa last year, 2020. It was called the Volunteers Program, and the purpose of it is to develop the capacities of renewable energy professionals, particularly the young professionals like young engineers, fresh graduates, students, through the concept of peer-to-peer mentoring. So the idea was to select 3 candidates who would be working with our team at Inertia for Africa, myself and Musaddaq and Zulfa and a couple of other colleagues of ours as well in the team. And when we announced it, actually, it was quite interesting that we received about 112 applications from over 17 countries, including I think 12 or 13 countries in Africa. So it was quite amazing. And we had 3 participants. One of them, Matthew, is actually here with us today in the webinar. And there was another person, Faisal from Sudan, who actually, after graduating from the program, he was selected to for a 2 weeks internship with the Microgrid Academy, the one offered by Rest for Africa Foundation. And now he's actually as well the president of the Association of Energy Engineers, University of Khartoum student chapter. So we're happy that our volunteers are accomplishing after finishing this program. And we also had another member, Jennifer from Kenya. We are planning to have the 2nd edition of this program quite soon. And we also have 2 other planned programs also focusing in the area of capacity building. One of them is about renewable energy research, which I'll be giving, and it's almost ready. So this is focusing on those who want to take an academic track in renewable energy research. What are the tools and the skills that they would need, and how can they develop themselves professionally in this area? And another program focusing on solar photovoltaic systems from like a more technical engineering perspective. Yeah, we believe that really equipping the young professionals with these skills is the most important thing that needs to be done to develop the market in Africa.
Okay, excellent. So thanks for that, Mohammed. You can all hear me, right? So let me just sort of share my screen as a wrap up.
There's one question, by the way, Tony. I think it relates to you from
I've seen that. That's on the EPC
Yeah.
side, right?
Yeah, exactly. Yeah.
I will address that. Don't worry.
Okay. All right.
I will address that. So I've seen that because we only have now a few minutes left, but let me just respond to that very quickly before we close the door. So just to respond to that very quickly. So how can the EPC help reduce the risk perception in Africa? So I'm sure there's many ways to tackle this answer, but the one that I would say is EPCs needs to deliver project with respect to international standards and making sure that they would deliver projects on time, on budget, and on quality. And if you're able to do that, obviously the investor know that whenever he contracts you for the project, then things were going to be okay. And that's ultimately how you're going to be bringing down the risk perception. Because at EPC stage, when the project reach EPC stage, that's supposed that we already passed financial close, right? So meaning that we already solve all the issue linked to the procedural issues linked to bringing the project to a stage whereby investor can confirm the money that is allocated to the project. Now it's all about now delivering the construction and building the asset. And what you don't want, what investors don't want, they don't want the project to drag on and on. You know, they don't want the project not to meet a quality standard, and they don't want project to be a lot more expensive than what it should be, right? Because all of that, it's what would increase their perception of risk. And I know that sometime in a beautiful continent, we have had these kind of issues, not only for renewables, but for all type of engineering. I guess that's why that question may be addressed to. So I believe if we tackle the time, the budgets and the quality, and we make sure that we deliver that on time, that will significantly reduce the perception of risk. So guys, so all that's left for me to say is I'm very pleased that you were able to join the session today. I'm hoping you have enjoyed. So thank you very much, Mr. Mohammed Saad and Mohammed Alaj as well, our partner. I think what we're going to do, we're just going to launch a poll survey very quickly. So if you're very kind, you guys, hopefully you can see, first of all, can you see, by the way, the poll survey?
Yeah, we can see it.
Okay, so I just want people to respond to that quickly, because this allows us to see how well we are responding to your expectation, right? So, and are we delivering, and see how we can improve ourselves. So I'm just going to leave it for another 10-20 seconds, and then after that, and then we can conclude. So while you're doing that, you can see as well on the screen, I have here the workshop that we're going to be running next Wednesday on the 10th of February at 1 p.m. GMT time. We're going to be talking about how do you step into the solar entrepreneurship, green entrepreneurship, for those of you who were thinking of doing that, right? So that's what we're going to be doing. The link is there as well, and I put the link into the chat. So make sure that you reach out. So let me just stop the poll and share the results so that you can see. So hopefully you can share, you can see the results. So in a nutshell, about 78% say that it was excellent content. So Mohammed, so all the so all the kudos actually goes to you. And obviously as well, so 67% like the format, and then I had a good experience. 67% had a good experience with the call. So excellent, guys. So I'm just gonna stop now. So yeah, that's all I had to share with you today. So thank you for joining that. We do our best to make sure that we can bring you more interesting topic. There's going to be more with Mohammed, and both Mohammed for sure. And thank you for connecting with us. So you have for Renewables in Africa, you all have our social media handles there. So make sure that you connect to us. You go on the YouTube, because we're releasing YouTube video on a weekly basis as well. And then like I used to always finish, so I just want to say to all of you, thank you very much. And in my language, we say Ngepela, right? So Ngepela to everybody. And then I wish you a fantastic day. So Mohammed, it was great.
Thank you.
Thanks, everyone. It was a pleasure being with you.
Bye-bye.
And thanks so much. Thanks.